Well, here we are at 12 o'clock. So I would like to thank everyone for attending this installment of our 2022 Home on the Range webinar series from the BC chapter of the Pacific Northwest section of the Society for Range Management. First off, I would like to thank the Kamloops Large Animal Veterinary Clinic for graciously sponsoring this webinar series this year. We really appreciate that they were able to do that for us. So I'm Amanda Miller. I'm the Vice President with the BC chapter of the Society for Range Management. We're hosting this webinar series again this fall as part of our extension efforts and to spread the word of Rangelands research and news across the Pacific Northwest section. So just a few housekeeping items. There's a bar at the bottom of your Zoom call. It has a mute button and a video button, and then there's also a chat box. We would ask you to please mute yourselves. It just helps with chatter on the line. And I would like to introduce our presentation for today. So today we have Bob Gillaspy presenting on resistance and resilience for rangelands. Bob is a member of the Society for Range Management PNW section, and he has been since 1982. He has a master's degree in range management from Washington State University and has recently retired from the USDA NRCS after 33 years of service to that organization. He's currently working part-time providing ideas and assistance to USDA NRCS at the national level, and we are very excited to have him present as part of our webinar series. So we would ask you to please hold questions till the end of the presentation or to drop them in the chat box down at the bottom, and we'll have questions at the end. So Bob, please take it away.
Okay, well, thank you very much for that kind introduction, and good afternoon to all. Yes,
It's not okay. It's not going to my earbuds. Well,
so I am happy to be here and look forward to your questions. We have about 15 minutes of slides, and then we'll probably open it up for questions. You can certainly type your questions in the chat. So resistance and resilience for rangelands and what do they mean is something that these terms are commonly used, resistance and resilience, by many of us, land users, managers, policymakers, and the general public, often in relation to climate change, changing disturbance patterns, and future viability of a land use or enterprise. Personally, I became concerned that these terms are not clearly understood, certainly not by me, which could lead to unrealistic expectations and perhaps disbelief in what is known about the science of ecology. My co-author, Shane Green, and I set out to provide a clearer understanding of ecological resistance and resilience so that users, managers, and advisors on rangelands can have mutually productive conversations about the impact of climate change and the changing disturbance patterns on rangelands that they use and manage. In this brief discussion, I will go over these 5 areas of first, trying to clarify a little bit, if I can, the terms that we're using and providing some brief definitions of those. We'll be talking about scale and how that matters, and I'll be talking about plant characteristics that one needs to think about in terms of resistance and resilience and the impacts on rangelands, and then the impacts of disturbances on ecological processes. What are ecological processes and how can one categorize them? And then a final slide of, okay, now what? What's next? So disturbances and definitions. Probably the most appropriate definition that we were able to find comes from Wikipedia. If you look up disturbance in parentheses ecology, and it talks about disturbances as being changes in the existing environmental conditions that cause ecosystem change. So a disturbance causes ecosystem change. In terms of ecological resistance, my initial go-to analogy is that mighty oak tree in a storm, and that oak tree resists being moved by the wind. I think there's a more general definition here of ecological resistance as the ability to remain unchanged when subjected to a specific external stress. So we need to make sure that we define what that organism, plant, or area of land is, and we need to be as specific as we can about the external stress. Ecological resistance is best measured by the amount of change in a specific attribute that the organism or area of land exhibits in response to that specific disturbance event. Now on to ecological resilience. My initial go-to analogy is the willow tree in a storm, the bending willow, which moves with the wind, as opposed to the oak tree that stands upright. Another analogy often used in resilience is the rubber band, which stretches with applied force, but then rebounds to its original shape when that force is released. So the definition of ecological resilience is the ability of an organism or defined area of land to return to a previous condition. In other words, within its ecological state following a specific external stress. Ecological resilience can be described by the amount of energy and disturbance that can be endured and still return to the previous condition. So resilience is all about returning to the previous condition, and the resistance is all about staying in your existing condition. The time required to return to this previous condition may be an important component to include in descriptions of resilience. So now we're going to talk about some scale. And first of all, scale matters when we're talking about ecological resistance and resilience. I mentioned the individual plant, but also we have ecological resistance and resilience not only at the plant level, but also at the larger watershed level, or even some other land resource region level. Ecological resistance and resilience operates at various scales. You can look at the various scales as depicted there on the right, from the point at the very bottom, X, Y, up to the patch, to the community, ecological state, and onward on up into larger and larger units. Ecological resistance and resilience also exhibit complex interactions across scales. So what happens at one scale can influence how at a larger scale its influence is manifested. Ecological resistance and even just resistance and resilience can be thought of at the ranch level. How resistant or resilient is the ranch to a specific disturbance? It could be thought of at a grazing unit level, pasture or range unit. I think for the purposes of this discussion, it's probably best to think about it at that management level scale, which I think of as being a little smaller than the grazing unit. And let's look at it at the ecological site level, because that ecological site has similar capabilities and responses to disturbances. Below that, one can look at the plant community. Within the plant community, you have different functional structural groups, woody species, herbaceous species, rhizomatous species, bunch grasses, or you might even go even more refined and look at the individual plant species. So scale matters when you're talking about resistance and resilience. Starting down at the plant level, individual plants' response to disturbance is really the ultimate base of that resistance and resilience and what happens. How does that plant respond to drought, to fire, to flooding? And then one can think about, okay, once we know what the individual plant does, we can aggregate that up to the plant community level. And how does that plant community respond to that same disturbance at that same time of year? Some plant characteristics to consider, and this list is certainly not exhaustive, would be lifespan of the plant. Is it annual, biennial, perennial, short-lived, long-lived? What is the timing of growth? Is it a winter annual? Does it grow? Is it a cool season perennial or a warm season perennial? Its growth, active growth stage is how long? Is it short? Is it long? Is it medium? Reproductive strategies in response to plant part removals are also important things to consider. So ecological resistance and resilience, need to think about linking them to ecological processes. The cause, which is the disturbance, and then how the ecological process is impacted. On the right is a diagram of a state and transition model. And some of the disturbances that are listed there include fire, exotic annual plant invasion, juniper encroachment, etc. And then you have changes from those disturbances from one community to another, or even from one state to another. Ecological processes is how plants interact with the landscape and the environment that they're growing in. And it can be really hard to pin down what is an ecological process or a category or function, or one can dive into the weeds very, very quickly. Shane and I found that it's probably best to think in broad terms here, and we found that these 5 categories of ecological processes are probably the best and most widely agreed upon what is an ecological process, and that in many ways they're more perhaps a group of processes. But so the water cycle is an ecological process, and nutrient cycles, energy capture and flow, the interaction between plant and animal communities, and soil movement and formation can all be thought of as ecological processes. I'll go through a few of these and subdivide them a little bit, and I think you'll get an idea of how we are thinking about them. So here's the water cycle as an ecological process in this table listed there on the left. And one can think of sample components or example components listed in the second column as infiltration, runoff, or uptake. And then it helps to think about what is it that impacts that component. So for infiltration, certainly the soil texture, the depth, and if there's an impervious layer are important characteristics to consider. And they're all at the site level, not particularly as refined as the plant. And if we go down to the last one, the uptake, then that's more a characteristic that is influenced by the rooting pattern and depth of the roots, which is certainly at the plant scale, not at the site scale. Next, nutrient cycles. There are many, many, many nutrient cycles. I've only listed 3 plus an other, which is an all-encompassing catch-all category. And one needs to think about what is that nutrient cycle that is perhaps most limiting in your environment to think about. That may be the most dominant one to consider. But nutrient cycles of various components mostly happen all at that plant level. It's how that plant can uptake and utilize those various nutrients. My last example here of an ecological process is energy capture and flow. And that really relates to things of timing of energy capture. What do you have in the way of solar panels or vegetative leaves out there? And then how does that energy transfer from plant to plant or from plant to animal, from site to site? So things to think about here are when is that plant actively growing or have active photosynthesis going on? Does it maintain its leaves throughout the year, or is it deciduous? And those are all plant scale processes. I think if you go down and look at energy transfer, the characteristics there are how does the energy transfer from plants to animals? That certainly happens at a plant and a site scale. And then between locations, how does that energy move, if it does? And that's certainly a process at the site scale. So in summary, I hope I've been able to provide a basic understanding and clearer understanding of the terms that are used in resistance and resilience, and that the descriptions and components that one needs to consider for resistance and resilience will vary with the scale that you're considering. Plant characteristics can be thought of as initial building blocks from which to consider resistance and resilience and the response of the rangeland as a whole to a disturbance. And ecological processes influence how the disturbances are responded to. So for what's next, a clearer integration of resistance and resilience into ecological site descriptions, I think, is necessary. It's a bit of a misnomer to say that it's an integration because the information is there. It's often contained in the ecological dynamics section of ecological site descriptions. But we can make it clearer and more readily presented by the use of tables to help present this information clearly and consistently. Tables can also be used to generate reports of user-selected disturbances in the ecological process so that that information can be useful in discussions between planners and decision makers. So with that, I'd like to thank you for your time and attendance. And there's contact information for both myself and my co-author, Shane Green.
Thank you so much, Bob, for this presentation. This is really excellent. So I'd like to open the floor to any questions. And you can either say them verbally or you can drop them into the chat box here. And so my question for you, Bob, is, you ran us through the different, some of the different disturbance the different disturbances that it can occur. From your perspective, is there any one that it would be would have a larger impact than the others, that should be, your primary management concern, or do they all play a similar type of role?
I don't think that there is any one disturbance on rangelands. They run the gamut from deserts to cold, snowy environments, and disturbances are quite varied across that wide range. And I think that's why I mentioned this reports for selected disturbance and ecological processes was because it depends on what is of concern, and the ultimately the landowner, the livestock owner, the land manager, or the people that need to determine what it is they're most concerned about in the near future.
Absolutely. And of course, the response of the ecosystem to that disturbance will be very variable across those different types of ecological sites that you'd indicated. Like a fire in a high mountain, snowy, cold area would probably have a different impact than something down in a more fragile desert system.
Yes, and they will vary depending on the existing conditions as well.
Mm-hmm. So is that, from your perspective, one of the most important messages, is that managing for your current state is key?
Well, I think managing for your current state is the easiest thing to do, because to move to a different state requires a significant amount of energy and inputs. But one has to recognize the limits of that state and the capabilities of that state to respond to disturbances, and try not to be close to an edge, if you will, of moving to another state.
Okay, yeah, that definitely makes sense. And so these, the report output that you'd mentioned, would that be available for all the different types? Well, is the intention for it to be available for all the different ecological sites across the United States?
Well,
Or-
eventually, yes.
Eventually, yes.
Probably not in my lifetime, to be perfectly honest. But I think the potential is there to utilize the information about resistance and resilience to focus the conversation between the manager and the ecologist and the planner about, well, what is really happening, and how does that plant community and individual plants respond to disturbance, and how can we buffer that?
I think that's the start of creating a really wonderful and very valuable product. And I'm interested to see how that goes south of the border, because it's definitely something that would have a lot of utility in our rangelands up here in British Columbia as well. So I'll be keeping an eye on how that goes. And I guess yourself and Shane are the best folks to get in touch with to see how that plays out over time, right?
Yeah, yes. And I would also say that Shane and I have submitted a paper on this, which includes tables and other information for publication in Rangelands. It's in the review process, and hopefully it'll be out soonish.
Cool. That's excellent. Well, hopefully that can be shared, once you guys reach that milestone and that accomplishment, hopefully it can be shared across the PNW section, because that'd be great to see. And it's definitely a very useful tool that will be coming out.
Well, we hope so.
Yes. So are there any other questions that from anyone in the audience? And Bob, is there anything else that you'd like to say on this topic before we end our webinar session?
Well, I guess I would say, while I titled this as Resistance and Resilience on Rangelands, because that is the audience to whom I'm speaking, these concepts so far, as I've presented them, other than the state and transition model, is applicable really to pretty much any ecological land use. Yeah.
We have a question from Jen. Bob, can you show the resistance definition slide again?
Sure. Let me find that. Okay. Did you have a specific question about resistance, Jen?
She just wanted a screenshot.
You're welcome.
I guess actually one of my last questions before we go, are there any specific systems you would say would have like be more resistant to any sort of external stresses than others? Like, are some systems, what would you consider the most fragile? What would be the most resistant?
Wow, that's really hard to say. Really hard to say. In general, I think that the systems that are in a wetter environment are probably more resilient. I don't know if they're any more resistant, but they're more resilient to change because they have the moisture is not a limiting factor. When you're getting drier and into more desert environments and things happen episodically, then that time frame that I mentioned can be important as far as, does it really have resilience, or is it just resistance that's fairly weak? And it doesn't really bounce back. Depends on your time frame, if geologic or human.
Yeah, that's very true. Unfortunately, so much of what we what we rely on is rain, which we have no control over. So it's good to manage with the parameters that we can. So if there's any other questions, I will open the floor to that. And in the meantime, I will say thank you so much, Bob, for your excellent presentation. And defining these concepts and how they can be implemented, and the ongoing work on creating a tool that can provide information for this across key and important ecological sites. Carlos, you have a question? Oh, you're muted. There we go.
I'm muted. Okay, can you hear me now?
Yep.
Okay, Bob, here's a hard question. So almost by definition, any ecological community, we're talking more about resilience and resistance, right? So can you, kind of building on what Amanda was saying, is there a particular example that you can mention about resistance, meaning something that has broken at some point and has not been able to return to a previous state, versus most rangelands land communities will have some level of resilience, meaning keep adapting or changing? So I'm just curious about, you have a particular example of this is resistance and this is resilience, in mostly resistance. Resilience is pretty obvious.
Yeah. So I would go to the state and transition model as my framework, Carlos, for describing that resistance and resilience. And if you look there in the number 2 box, let's see if I can. So that this whoops, sorry about that. That wasn't supposed to happen. So if you can see my cursor, this number 2 box, shrub step with annuals, has a state box. And then within that state, there are 3 communities, plant communities described. The plant communities have relatively low resistance to change, but they do return. So they could be thought of as having a higher resilience to change and disturbance. But once that state moves across a threshold, say to state 3, then that is a fairly high bar for it to move, and it does not move back very easily. So that would be an example of a low resilience, low resilience because it doesn't bounce back, but it takes a fair amount of energy or ecological change to cross that boundary. So it could be thought of as a higher resistance to change.
Yeah, thanks, Bob.
Yes, thank you. Great food for thought. All right, well, we are at time. So I'd like to say again, thank you so much, Bob, for your presentation, this excellent food for thought that you've provided on the definitions of resistance, resilience, and how they all intermix and interplay. Thanks everyone for joining us, and please join us again on November 8th when Nick Hamilton will present on the province of BC's range ecologists working for ecological and social landscapes in a time of rapid change. So thanks again, everyone, and have a wonderful rest of your day. Bye.